Hello everyone, welcome back to our video lecture series on AutoCAD. Through the previous sessions, we had discussed how we can create 2D drawings in AutoCAD, and if you have been following all the lectures closely, then by this time you would have equipped to prepare any drawing in 2D. The basic skills required for preparing 2D has already been covered, and in certain cases, I haven't demonstrated or explained all the options, but the basics has been dealt in detail. So now you will have adequate skill sets to explore further. Like maybe if you want certain type of result or certain type of drawing, and if you cannot properly think how you need to proceed for that one, then there may be certain other options available in AutoCAD. So you can just try exploring that. I mean, Google is a very good resource. Like in fact, we have AutoCAD knowledge base, which can be used very well, wherein all the details are given and all the related comments and system variables and other details are given in detail, so that you can go through that, get some keywords from that one, then again Google with that. Then you'll have enough YouTube videos also for demonstrating various types of figures or various types of options or functions in AutoCAD. Okay, and another important aspect is softwares like these. If you want to expertise in that one, or if you want to remember it properly, or if you want to use it properly, then practice is the best option. So the number of drawings you prepare or the number of time you spend in using this software will enhance, or I can say in mathematical, or it will be directly proportional to the expertism or the level of expertism you will be having as well. I mean, that is applicable to majority of the softwares of this type, or even programming tools. Okay, so having covered all the 2D portion, we'll just give the third dimension to our drawing. So we'll see how we can create 3D drawing, or how we can move from 2D to 3D. And while moving from 2D to 3D, what are the important aspects what we need to think of? And one important aspect is 2D is the base for 3D too. We need to know well how we can prepare 2D drawing. Then we'll use certain comments related to 3D, and we'll move to 3D drawing. Okay. So in this session, we'll be talking about the basics of 3D. So when you say 3D, rather than creating the 3D, we'll also have to look how we can look into 3D, and even the display, or when we take the printout, how it has to be represented in a 2D plane. See, our system or the paper where we are going to take printout is basically a 2D surface. So if you want to represent this 3D surface, 3D object in a 2D surface, then certain type of visual help also we need. Okay, so how we need to look into the object, how we can see the object, how visually we can represent those things. So those things also will be covered in basic things. So after this, I think I may have a couple of videos also to show you how you can create 3D solids. And when I say solids, like we can create different types of 3D models as far as AutoCAD is concerned, which we will be discussing initially. And then we'll discuss about viewing 3D models, I mean, like in different ways. And with that, we'll and then some discussion on the planes in which you can prepare your drawing. So these are the agenda as far as this particular session is concerned. So once you complete all those things, I'll be concluding this video, and we'll proceed further. So let us move to AutoCAD environment and see what we have. If you see this figure, you may be remembering, like in one of the exercises, I think it is part 19, in part 19, or the last figure what we have prepared as far as 2D drawing is concerned. We took an isometric view of a solid model and prepared the different views, different orthographic views of that model. So in this session, I'm using that particular model to demonstrate you how, or demonstrate to make you aware of the basics of it, right? The first and foremost thing is like now when we think about 3D, we can think of different types of 3D models as far as AutoCAD is concerned, right? So the first session, what we'll be thinking is what are the different models what we can prepare, or what are the different types of 3D models what we can prepare by using AutoCAD. Okay, so here if you see the first one here, the model what will be shown here, I'll just zoom that. I can see that this somewhat resembles or you can visualize this as the object what we have seen earlier. So here only the edges are shown, right? Edges are shown as lines, or you can think of the object being created by using what is that, wires. Wires are welded together or tied together to get the shape of that particular model. So this type of modeling, or this type of model, we can call it as wireframe model, right? So this is wireframe model wherein only the edges are clearly visible. Like now we don't have anything inside this one, so this surface is blank, I mean like hollow, or the entire portion is blank or hollow. So these type of drawings are called or this type of 3D models are called wireframe models. I'll just take a break. Okay, so this type of models are called wireframe models. So in wireframe models, it is something like taking some sticks and sticking it together so that only the edges are shown. So this that is what is termed as wireframe model. And in certain cases, wireframe model is sufficient for us. For example, if you are thinking of a new machine or a new item, and where you are thinking it conceptually, and you are just want to explain it to somebody, or you want to make some drawing out of that one, then it is not possible for you to create the complete solid out of that. You may be using some pencils to draw some line sketches and create a model. So conceptual models and all those things, you can use this wireframe model to show it to or discuss it with your colleagues or friends. Similarly, in certain cases, if we want to do some static force analysis or something like that, where we just want the outline of the object, then also we'll be able to use this type of model. So this is the very basic model as far as this is. Okay, now if you move a little bit further, here you can see that, I mean, a lot of lines, in fact, like, I mean, all the faces are covered with something like a mesh. And so this type of 3D model is called mesh type, right? So you can create mesh type of 3D models in AutoCAD. Here, instead of showing only the edges, the surface will be shown, and surface will be shown as meshes. You can think like you might have already seen some wire meshes, like I mean, in our campus itself, we will be using some wire meshes to have a protective, like in a case in the trees which we will be planting, like the saplings which we will be planting. So if you think like your model has been created by using those type of meshes, then you can think or consider it as a wire mesh type of model. Okay, so this is the wire mesh type of. Now the next one is surface model. To view it more clearly, I'll just change the display scale. I'll discuss these things later. Now here you can see that all these are surfaces. All the faces are made as surfaces. See, if I delete you can see here it is hollow inside that one, so the other side it will be seen. So all the here I just inside it is hollow, only surfaces are there. So you can create the objects or solid models by using surfaces. Like now all the surface will be created as a as a sheet. You can just think of like cutting paper and sticking on the faces, so that inside will be hollow. So this type of models are called surface models. So here will be focused on surfaces. All the surfaces will be displayed. So but there will be nothing inside that one. Inside it will be hollow. So something like this you can think as surface model. And surface models is very useful. Like if you want to create smooth curved surfaces, or wherein your interest is more on the aesthetics, like now how it will be looking, how we can like properly give curves to the edges and all those things, then the better option will be to have surface model. And the last one among this is solid model, which is most important. And here it is something similar to the object what we are making. We can think this as something like virtual prototyping. The entire model is created as such, right? So there will be full of solids inside. So whatever structures the original model will be having, the same type will be creating this one. And you can have, like, if you assign a particular material to this one, then will be able to find out the weight of that one. You can calculate the volume of this thing, and when you can calculate various other properties. So this actually visualizes the entire thing, and you can section that and take the sectional drawing. You can see what is inside, how it looks, and we can view it from different angles. So all those things can be done. But in other cases also visualization is okay, but in solid model, it actually we are trying to replicate the original solid in a virtual environment, or we are virtually prototyping that particular model. Okay, so these are the 4 different types which is possible as far as different solid models which is possible in AutoCAD. So all these things can be created in AutoCAD. So this is wireframe, and this is mesh type, this is surface model, and this is solid model. And our discussion will be on solid model. I'll not be discussing on all these aspects. Once you are familiar with solid model, you can just go and revisit the other type of models, and we have suitable comments available here for creating this. This is for solid, this is for surface, this is for mesh. And one important aspect which I didn't discuss initially is you might be seeing a difference in the comments which is available here, or the toolbar or the menu which is available here. So I just moved from our good old drafting and annotation workspace. This was our earlier type of workspace. So I moved from that to 3D modeling, so that I'll be getting more 3D related comments here, right? So that I can pick the most appropriate comments from here rather than typing the comments on the command line. Okay, so here you can see this solid, surface, and mesh. I mean, once you are familiar with solid, then you can just browse through the other tabs, and all those things will be pretty clear to you. And even there are a lot of helps, like even in AutoCAD itself, if you keep your mouse over that one, then some text will be popped up, and if you read that, I mean, it will give the basic idea how to use that particular command, and that will be sufficient, like, you know, as you are covered major portion of the other drawing. Okay, so that is about different types of models what you can create as far as 3D is concerned. Now, first we will see what are the different types in which the model can be displayed on your screen, right? This here you can see it is displayed as wireframe type, and this model is wireframe, and in solid. Even if it is solid model, every time, like, we may not be required it has to be shown as solid. Sometimes you may want it as a line sketch or something like that. So there are different options for displaying the solid model in your screen, or in your, or even when you are taking printout. So those options are available here. So if you just click here, you can see the various options here. The first one is 2D wireframe. So if you have 2D wireframe, everything will be shown as in wireframe itself. Like, this is something similar to what we had earlier. Like, when we are preparing 2D drawing, basically we were using this 2D wireframe. This is pertaining to 2D. So this will I mean, show the models as if we are in 2D space, right? Then we have this conceptual type of model, wherein, like, I mean, where you are going to visualize that in a better way. Right now, to show the image, it's edges highlighted and all those things. And this is hidden. Hidden means only the outer edges will be shown. Like the hidden edges inside will not be shown, so the surfaces will be clearly visible and the outer edges will be. Then we have realistic. Realistic is a step again above conceptual inference. So how it will look in real world. So in real sense, how it will be looking, that is what this realistic means. And we have other options like shaded. Shaded, all the edges will be shaded. So here I am getting it in different color shades because I have given different colors here. Right, I have given different colors to different layers, and I have prepared all these things in different layers, so that if I want, I can switch off. It's for convenience I have made something like that. So, and because of that, you are seeing it in different colors. So whatever color you are assigning to that one, based on that color, the object will be shaded in that particular. And we have one shaded with edges, where the edges also will be highlighted. Right, here being surface, like the number of these lines are also seeing, and in solid model, the edges are highlighted here. The other and we used only shaded, then the edges were not highlighted. So that is that option. Then shades of gray. So here, whatever color we are getting, that will not be considered. So all will be getting in shades of gray. This is another option what we are having. Then sketchy, like now, so if you are preparing it like pencil sketch or sketches, then how that will be displayed in this, that is sketchy type. And this maybe if you want to have some presentation or something like that, you can use this type of. And this is wireframe, which will be somewhat similar to the wireframe what we have already seen. The earlier was 2D wireframe. In the case of 2D wireframe, we were basically in 2D environment. Now we are moving to 3D environment, and it is shown as wireframe. The one difference what you can see is the UCS what you will be seeing here. Just look into this UCS. I'll be moving back to wireframe. See, now the 2D, that basic UCS is shown, but when I'm moving to wireframe, it shows like we are in a 3D environment. So that is about wireframe. And we have X-ray also, like it's just like seeing within the object also, like see through. So these are the different options through which you can use. I'm okay with shaded with edges. With shaded file. This is okay. So this is how you can see your drawing in different way, or the way in which you can view your drawing, or the display, how to change the display of your drawing to match different properties. Okay, now we'll also see when you have been preparing 2D drawing, what you have seen is something similar to this. We are seeing a plain paper, right? And here we have the paper was placed before us, or it is placed perpendicular to our view, like perpendicular to the vision of the view. So we are drawing on a paper, and which the paper is placed in front of us, so that is perpendicular to our view. So only in one plane we are looking. But when we think about giving the third dimension, we have a Z direction also coming. So we can see it in from different angles, right? So far what we are seeing, we can say it is the plan, right? Plan or the top view. So at present, whatever drawings we have prepared, we were moving only into, we were looking only into from the top, or it has been placed vertically, and we are looking through that. Or it's just like drawing in a piece of paper, like, and it's in front of us. Now, if you have the third direction also coming into picture, so we have something. So we can look at it from different angles. Like now, I mean, you can look at it from the top to get the top view. You can look at it from the front to get the front view. You can look at it from the right side or left side to get one side view. Then we can from the bottom to get bottom view. Also, you can look at certain angles. Like now, if you're looking at in a particular angle in southwest direction or northwest direction, we'll get northwest isometric or southwest isometric. So the view can be rotated, like it can be rotated or it can be turned. So how to view our model in that one, that is what we are going to discuss, right? So here, if you see here, you will have certain standard options, like this is top view, bottom view, left view, right view. I'll first show the front view. See, now the view has been changed to front view, right? The object's view has been changed to front view. I'll do one thing. I'll just take one model. I'll just make all other models off so that it will be easy. Otherwise, I'm also. So I have only one solid model here, which I'll zoom. Right. So this is what I'm. So this is front view. So if you think you can see this as my top view, what we have seen earlier. So from here you can change to some sorry, to some of the standard views. So if you want to left view, you can see that our object is shown with left view, and you can look into the UCS also to see where this x direction, y direction, and z direction. Similarly, we have isometric views also. This is southwest isometric, wherein you are looking at it at an angle. So by using this, we can move to any of the standard moves, and also we have an option called parallel and perspective view. Perspective view, I think you might have already learned like the perspective projection in the earlier semesters. You can think on that particular line. So basically, to get the actual visualization, like it will be better if you go to the parallel type of display. Okay, so this is about the standard type of views what you can do, and also we have the view cube here, right? So this, if you click here, you'll be getting the top view or plan, or if you want to rotate that, like then you can click here so that it will be rotated, right? Zoom and pan as usual you can use by using mouse and other things. And also we have a home button here which will give you this southwest isometric view. So if you are if you want to go to southwest isometric, you can directly click this home button here, this house here, then, and you can see that the background is changed because now from parallel it has moved to perspective. That is available from here also. If you click here, sorry, zoom that. If you click here, that will be going to this southwest. If you right click there, then again this parallel perspective and other options are available. So you can just move to parallel so that the older display will be right. So this is about viewing, and also if you want to rotate, or if you want to see a particular thing, you can click here also, right, in anything possible. And once you are in a different view or different angle, and if you are interested in going to the top view again, top view, so when I say top view, it is the plan view. So I can use the command plan, PLAN. Then plan will have different options, like now we'll have current UCS, UCS and world UCS. We'll talk about this UCS in another couple of minutes, and before that, so you'll have to select one UCS here, which you'll understand later. At present, I'm just taking the world UCS, so that I'll be going back to the plan of the first one which we have drawn. Like now, hope you remember when we discussed about UCS in 2D drawing, I have explained something called world UCS, and this WCS stands for world UCS. That is the base of AutoCAD. We can create our own UCS. That is what we will be going to see next. But here, the world UCS remains as such. If you want to draw something in some other plane, we'll have to create some other UCSs that will be explained. Okay. So this is about viewing it in standard or in certain preset views. Also, if you want to see it rotated, or if you want to put it in a particular angle, you have an option here which is termed as orbit. Right, the orbit has got three options here: orbit, free orbit, and continuous orbit. I'll demonstrate all these things now. First, we will see orbit. When you see orbit, you can see that our mouse has been changed into something like having three orbits, like in X direction, Y direction. You can just click and drag whichever direction you want. You just can click and drag so that our object will be rotated in the way you want. Right. So this is this orbit, sorry. And also we have free orbit also. Free orbits, we will be getting a circle here, and you can again rotate in the same manner. This will have certain restrictions, like which will be hinged to a particular point, and from that point we will be able to rotate. So by using this free orbit and orbit, you can rotate or move your object to any of these, any position, or just see in any angle you want. So just by using mouse you can do that, and using this method. And also if you want to have continuous rotation, like then you can have this continuous orbit. So continuous orbits, I'm just clicking here, dragging it a small distance and leaving it. Now it is rotating in that direction, right? If I want to stop, I can stop. And the intensity, the speed in which it will be rotated will be depending upon the length of the arc or the length of the line what we are drawing. See, I'm clicking here and I'm just moving it to a greater distance. Now you can see that it is moving in a faster way. Although the object is out of my distance, so I'll just zoom so that I'll be getting object here. Continuous object. Now you can see it is a little bit faster. And also you can see that XY plane also, where as we have made the grids on, you can see that grids also in the plane. So this is about continuous object which will continuously rotate our object. Okay, now see here, if you see, now just I'm just stopping here. You can see some lines here, and I'm also just trying to rotate. I'll make this free orbit. Now you can see something, a plane here. See, when I click here, when I move here, you can see some lanes, grids, and actually it's a plane. And this is the plane in which we have drawn our initial drawing, right? Where we have prepared the base, and then we have given a third dimension to that one. So we'll be preparing that in a plane, right? When you prepare drawing in your class earlier in the semester, so you need to have a paper to draw something, right? Only on the paper you can draw something. So here, instead of paper, I need a plane to draw something, right? In extreme cases, we can draw on some surfaces also. But normally, the concept here is we need to have a plane in which we are going to draw, and always we can draw only in XY plane. There are few comments in which we can move in any plane. Like now for line comment, you can start from any point to draw any point. That is, you can draw it in 3D space. Similarly, we have 3D poly, an equivalent of polyline, which we can draw in different planes, right? But for all other, like circle, arc, or like rectangle or other things, you can, other objects, I mean, you can draw it only in one plane. So you need to define that XY plane. And that is defined by this UCS. That is the relevance of UCS. So whenever you want to draw something, first you need to define in which plane you are going to draw that one. I'll just, or this will discuss you the concept of this one. I'll go back to or copy, right? Okay, I'll have this isometric. Yep. Right now, if you see, I'm just zero layer on, solid off, turn off the current layer. I will make zero layer. Right now, now if you see, you are having this XY plane here, right? The XY plane is placed horizontally, or if I want to draw something like a circle or something like that, see, I'm drawing in the XY plane. You can see that I'm drawing it in the XY plane. Now that is I have drawn something like that. You can see that as XY plane, or you can think that as the top plane. Here, if you look into that one, see this plane, you can see that is the top plane. So you can have parallel planes also. So this is at 0, 0, this is at 0, 0 of Z, and this is at a distance, I think it is around 500 or something like that, above the base 0. So now the UCS is in this direction, it's in XY direction. So whatever figure I will be drawing will be in this plane. So our plane is aligned to this rectangle, right? The XY plane is aligned to this one. So for example, like now I'll just show you, I'll just draw a rectangle here. Even I'm clicking this point and this point, but see how the figure is coming. The figure is coming in this particular plane, or it is parallel to that XY plane, right? So we will be able to draw only in the corresponding XY plane. Okay. Now, what if I want to draw something in my front plane. So the front plane, I will show where my front plane will be, like I am on it already. Yeah. So this green line, green rectangles what you have seen is front plane, and this is a rectangle parallel to the front plane. See, even now my x plane remains the same, right? But so I will not be able to draw something here, right? Again, I will show one circle. Yeah, I'm just picking one point and drawing that one. You can see that it is parallel to this plane or it is in this plane, right? Now, what I should do if I want to draw that circle in the front plane, then I need to redefine my UCS, right? I need to redefine my UCS in such a manner that my this rectangle will be my new xy plane, right? You can do it in different ways. We have different options to change the UCS. That is what we are going to discuss now. I'll not be discussing too many options. I'll be just discussing about the standard UCS and one important option or the default option in that one, that is 3-point UCS. Or the other UCS you can try yourself, like now, depending upon your convenience. And most of the cases, if you have these two, if you know how to create the standard UCS and this 3-point UCS, then majority of the cases you will be able to, majority of the drawings you will be able to prepare, right? So here you can see different options. Right? I am just changing this to front. Now just see this XY plane has been changed to front. I'll repeat it. I'm just moving back to world. When I move back to world, you can see that XY plane is like parallel to what I can say, my keyboard here, right? Now, or parallel to this line, or this is our world UCS, right? Now, when I change these to friend, you can see that XY plane has been changed like this. Now, I'll draw a circle or a rectangle. I'll draw a circle like now. Just I'm making this the point somewhat similar to the earlier one. See, now the circle is oriented in a way that it is parallel to this plane or it is in this particular plane. So to draw something in a particular plane or in a different plane, you need to define that particular UCS, or you need to reorient your UCS in such a manner that your XY plane is aligned to the surface where we want to draw, or the paper which we want to draw. So it is something like, no, I mean, similar to moving your paper. So you have a paper. Normally, what we'll be doing, we'll be drawing it in a paper like this, and that will be viewed like this. So if you want to draw something here, then I need to change the paper like this, and then you need to draw it here. So the same concept we are using here. So we have other standard options also here, like top, bottom, left, right, front, and back. So you can use various other options. Suppose if you want to draw something here, I can use this left or right. Like now I'll have this left here. Now just see what happens if I take a circle and I'm just trying to draw that. See, circle is parallel to this plane or on that plane, right? So this is how we can have different UCS, and in fact, if you want to have something in a different angle, like I'll show it. I have a angle plane also. You can see something like this, right? And I want a circle on this, something like this here. So now you just see my UCS is turned. My where is my XY plane is oriented in no, XY plane is in the same manner, but I want to draw something here. So if I draw the circle here, right, it is coming in XY plane. I don't want this like this. I want the circle on this plane. For that, I need to reorient this UCS in line with this one. Okay. So for that one, I can use this 3-point UCS. This is one option which I will be explaining here. The other options I will just show you here. The different options I will not be demonstrating. You can just understand that, like, no. So here in 3-point option, when I have this 3-point, first it will be asking me the origin. So where should be my origin, right? So I am going to pick this as my origin. Then it will ask me what is the x direction, positive direction of x, right? So I can mark this as positive direction x. Then I will show the positive direction of y. So once I give all those things, you can see that x, y is oriented in the sun, and you can see the grids are changed in that one. Now just let us see if I take a circle and if I start drawing that one. See, coming in this one, and I'll draw it in this plane itself, so that you'll right. We are getting this will be on that particular plane. You can see it in different angles. right? You can rotate it and see it is on this plane itself. So I have drawn this that plane. Okay. Fine. So this is about different planes in which we are going to draw, or we can say different UCS. The other options what we are having is you can have named UCS, or once you create a UCS, you can save it in a particular name that can be used. And these are the standard UCSs what we will be having. Right now, world UCS is something what we are seeing, and if you want friend or back, and you can use those options. And this is the one which we have discussed, that is 3-point UCS. This is z-axis vector, that is if you want to rotate the UCS in z-axis to a certain angle with respect to the z-axis, that can be used there. Similarly, if you want to change the origin of the current UCS, that can be done. Then you can have various other options also, like UCS here, see it is aligned to object, or if it is aligned to face. If you want the UCS to be on one face of an object, you can use this face option there. So all those things are if you understand that, if you go and keep your mouse on that one, then you'll get the option. For example, here it is UCS previous. That means I have created some UCS and I moved from that to another UCS. Or if you want to go back to the earlier one, you can use this UCS previous option. So a lot of options related to UCS is available that you can use. Okay, so that is one important aspect. And one more thing which I would like to discuss as far as UCS is concerned is, see, when you change the view from here, now I'm just moving to front view. Now I got front view. Now the UCS is world UCS, so it is not changing. Now I will just change it to front view. Now also, if you see the front view, you can see that the UCS is not changed. It remains like the set direction in the top and other things. So okay, I'll have from previous to the front view, the top view itself. So whenever I change the view from here, the UCS is not changed. And in some cases we may want, when you are going to the front view, I want to draw in something in front plane. When I am going to the right view or the side view, I want to draw something in the front. So you want automatically change the UCS also according to that one. So for that one, you can change the value for one of the UCS, one of the system variables related to UCS. That is UCS ORTHO. This is UCS ortho. If you see the UCS ortho value, current UCS ortho value I have set as 0, and most of the cases by default it will be 1 in your system. So you can take two values, 0 and 1. Just a minute, I have called. Okay, so if you change the value to, or the UCS ortho can take two values, that is 0 and 1. So normally by default UCS value will be 1 in your system. So if the UCS, not the UCS value, UCS ortho value, if the UCS ortho value is 1, now just see what happens. Like now I'm just making a move to this to front view. See, when I change the view to front view, you can see that the UCS automatically changed as front view here. So here also you can see that the change. I'll move to right side view. Here also you can see the UCS is changed right side, and here the XY side as XY has been aligned to our plane, right? So by using this UCS ortho option, and whenever you move to a standard view like left, right, top or bottom, then automatically the UCS also will be changed, so that you can draw in the same in the plane in you want without making any modifications. Okay, so this is how you can change the UCS, or how you can define UCS. And it is required to define a UCS if you want to draw in a particular plane, right? So in any plane, that is something like, if you do not have paper, then you cannot draw. So we need to have a paper. Here the paper concept is the plane concept. So we need to define the plane first, then we need to draw in that particular plane. So these are some of the basics as far as AutoCAD is, AutoCAD 3D is concerned. So with that, I am concluding this session. So hope you understood the concept of UCS. So we'll deal more about 3D comments, and I will have a small revision of this UCS also in the next class. So I'm concluding this now. Thanks for watching. Stay home, stay safe. Thank you. Bye.